Really it is. Yep. Yay for you. That's what Rebecca was saying. Yes, and I'm like, you are like the best blood type for being a donor. You're like the worst blood type for getting anyone's blood, if you were ever in an accident. There we go. All right, today we'll see how far we get. I printed these off. They're not in color. I can hand around some colored things if you want to shape. I don't know. Because I'm talking and I see two people. I don't know. We are talking a lot about the different parts of the heart, and a lot today, the flow of blood through the heart. We'll continue it on Tuesday. But although I can keep talking this, sometimes it's nice to have a visual in front of you. Because I tried to draw my heart up there, and I'll use it and reference it, but again, I'm not an artist whatsoever, so I was like, right before here, I'm like, I'm just going to print a picture. Any picture I print has to be better than anything I'd try to draw on the board. I'm going to hand colors out here in a second. I literally grabbed whatever was on my desk. So I got some red, I got some blue, and I'll talk about why one's red, one's blue. Let me just hand some out. You guys are going to just have to share. You have red and blue? Look at you all prepared there. There you go. All right, so the heart, we talk about the heart as it's divided into two sides, right and left. And when I say right and left, we're talking about the person's right and the person's left. So as I'm standing here, this is my right side and this is my left side. So this is the right side of my heart. Even though when it's drawn on the board, it's on the left side. That's because you have to imagine this is anatomical position and you're looking at someone's heart. That's someone's heart. So I'm like, this is the right side. Now, the right side of the heart receives oxygen-poor blood from all the tissues. So blood that's been circulating around your whole body, the same picture's on my next slide in color. But blood that, well, I'm just going to scooch to it. There we go. So if you want to know what's red, what's blue, there you go. So the right side of the heart is receiving blood that just got done circulating around your entire body. So it got done dropping off oxygen at all the tissues that needed oxygen and picking up carbon dioxide from all the carbon dioxide that was produced in the tissues. And all of that tissue, that low oxygen blood, is going to go into the right side of the heart. Now, it's going to come in from the top into our first chamber up here. And our first chamber is called the right atrium. In lab, not next week, but the week after, we do all this with the heart, and you'll dissect a heart too. How was the eyeball dissection? Now, and I'm like, I might as well label a few other things while I'm up here. Right below the right atrium is the right ventricle. And then from the left ventricle, or the right ventricle, is going to get pumped out of the heart. And I'm like, through what's known as the pulmonary trunk into the pulmonary arteries, and anything pulmonary has to do with lungs, this is low oxygenated blood. We need to send it to the lungs to go pick up oxygen. It's once in the oxygen, the blue turns to red because it's now oxygen rich. And that oxygen rich blood that's coming from the heart, from the lungs, sorry, that oxygen rich blood that's coming from the lungs is going to enter into the left atrium and then down into the left ventricle, where it will get pumped out to the rest of the body to go send oxygen to all the tissues you need. Now, I know some of you guys have to share colored markers, so color it in and find someone around you that might still need a colored full marker or pen or highlighter or whatever else I had. Because as we talk about the different, direction of the heart, you have to know the flow of blood through the heart. You have to. You just have to. You have to know it in this class. You have to know it in advanced class. You have to know it in pretty much any other type of another class that has to do with nursing, things like that. You have to know a flow of blood through the heart. You have to know what allows blood to flow in one direction, all the different valves that blood can go through but can't go backwards. But it's always good to know the left side of the heart has oxygen-rich blood. The right side of the heart has oxygen-poor blood. Yep. The right side of the heart has oxygen-poor blood. The left side of the heart has oxygen-rich blood. Now, some other basics about the heart. Size-wise, it's about the size of the fist. And I'm like, so the size of your fist is about the size of your heart. It sits in the mediastinum, the middle part of the heart. It's its own little chamber right there in the middle of the thoracic cavity, between the second rib and the fifth intercostal space. And it sits a little bit to the left of the sternum. This is why when you say the Pledge of Allegiance, where do you put your hand? On the left side, because your heart sits towards the left side. And I'm like, looking at it, here's your sternum right there. The majority of your heart sits towards the left side. I mean, there's still some on the right, but it sits more towards the left than to the right. Now, on the outside of it, we have what's known, well, it's a double-walled sac. We literally have a little tiny cavity in there. But on the outside of that cavity, we have something known as fibrous pericardium. It looks fibrous. It's there for some additional protection of the heart. It helps anchor the heart in place so it's not, bobbing all around when you run around. So it anchors it to surrounding structures, and it tries to prevent overfilling of the heart. So not too much blood can ever get dumped into the heart at once. And I'm like, there's only kind of so much stretch that can go in there. Now, underneath this fibrous pericardium tissue, this is when we get into this cavity that has two layers. One that's attached directly to the heart, and one that's attached to this fibrous pericardium, and then there's fluid in between. That's this part. And I'm like, so beneath that, you have a two-layered serous pericardium structure. Again, you're going to see cardi in a lot of words. Peri means around. And I'm like, but you have two layers. You have the outside layer called the parietal layer, and you have the inside layer that's attached directly to the heart. That's the visceral layer, also known as the epicardium. So when you guys did in first lab, when you had to know visceral and parietal, the parietal always covers the chamber. The visceral always is attached directly to the organ. And so the visceral layer is attached directly to the heart. It gets two names. It's also called the epicardium because although it's part of this pericardial cavity, it's also part of one of the layers of the heart. So they also call it the epicardium for the layer that's on top of the heart, because that's what epi means, it's on. Now, in between, that cavity is never empty. There is a fluid there. And I'm like, it's to reduce friction. I'm like, what happens to temperature when you've got friction? It goes up. If you rub your hands together, because it's cold outside, temperature goes up. Your heart is always beating, I hope. I'm like, your heart is always beating. That constant motion can generate friction. So I'm like, we try to reduce that friction from that beating by having fluid on the outside of the heart. So it's not increasing the temperature and doing damage to the heart itself. Now, what can happen, because again, there's always bad things that can happen to anything, is if there's inflammation of that pericardium. And I'm like, it happens. Sometimes it's viral infections, sometimes it's bacterial infections, sometimes it's damage from something else. And I'm like, but if you have damage to that pericardial cavity or either of the layers on either side of it, inflammation is called pericarditis. But you're going to reduce, well, it's there to reduce friction, and now you've got friction. That with a stethoscope, your heart beating will actually have like a creaking sound to it. Is because there's rubbing, there's now friction, is because you've got too much inflammation around that tissue, and you don't have that fluid in between protecting the two layers from touching. They're going to touch and they're going to creak when your heart beats. You can also get something known as cardiac tamponade. It's excessive fluid that's in that cavity. And I'm like, and I just saw a little video the other day where there was actual blood in that cavity. If you have a lot of fluid in that cavity around the heart, is your heart going to be able to beat properly? Like excessive. That excessive fluid is going to be pushing down on the heart, and your heart's going to have to try to work extra hard. It's because you have all that fluid around it. The main thing, what they do for that is they have to go in right towards that cavity, and you hope they know what they're doing. And I'm like, and they will syringe out some of the fluid so that your heart can still beat normally. Now, so there are 3 layers of the heart wall. The epicardium is that bottom layer of the cavity. Then there's the myocardium and the endocardium, which are my next 2 slides. Anything myo means muscle. We just got learning muscles. A lot of things in muscles had myo in it. Well, the myocardium is really the muscle layer of the heart. It's the part that's doing everything. The interesting part about your heart muscle, it doesn't just run in nice straight lines like your skeletal muscle does. It wraps around the atria, wraps around the ventricles in kind of these swirling patterns. Now, in there, they will crisscross, they will interlace, and part of that, and I'm like, all this crisscrossing and interlacing, and I'm like, they form that way for a reason. A lot of that is to help with electrical signals making it to all the different places of the heart. So it helps, limit the action potentials, the electricity, to very specific paths. We want the top part of the heart to contract, then the bottom part. And I'm like, always top or then bottom. And I'm like, and the muscle is arranged to help with that. It also supports some of the big, huge vessels that are supporting it. You have lots and lots of vessels. And I'm like, you've got big, huge arteries and veins that are going to and from the heart. That muscle is there to support that so they don't fall over, bend, kink. And I'm like, and it just, anchors all the muscle fibers together. Now, the endocardium is the inside lining of the heart. So you've got the outside epicardium, the actual muscle tissue itself, and then the endocardium, endo means inside, so it's the inside lining. So it lines all of the inside of the chambers. It's continuous with any of the blood vessels that are leaving the heart. It's just one continuous layer on the inside of the heart and out the vessels themselves. Now, I could try to draw an oracle, but I'm going to show a picture. And I'm like, at the very, very top of the heart. So you've got these 2 chambers at the very, very top. But on the outside, there are some appendages, because these atria are not very big. So why can't we get to the dissection? We got like a week and a half. And I'm like, the atria are really small compared to how big these ventricles are, which means there's not a lot of blood that can fit in there. And sometimes we need a little bit more blood in there. And so there are some appendages that hang off that kind of expand out a little bit like a balloon. That's the auricles. Now, they look kind of bumpy. I'm going to find a picture. And knobby-like. That's an auricle. They're kind of bumpy and nodule-like, but it allows for a little bit further expansion of the atria. So we're going to talk the atria first, and it has these little, I'm not going to try, little bulgy areas that can expand more to receive more blood. These are thinner walled than the ventricles are. They don't have to do as much. The main job of an atria, or atrium, singular plural, and I'm like, is to pump its blood into a ventricle. Is that very far away? Nope. It's like, oh, my job is to pump blood there. That's it. It's not very far. They got the easy job. A ventricle's job is to pump blood out of the heart, either to the lungs or to the entire body. That's a whole lot farther than just right next door. So they're smaller, they're thin-walled, they don't contribute a lot to the moving of blood. Blood moves around the body really because of these ventricles. These are kind of just weak, like whatever, I'll push my blood to a ventricle, but that's as far as you get. The ventricle's job is that huge squeeze to generate all the blood pressure to move that blood through your entire body. Atria don't do a lot. They just pump blood across. Now, your right atria is going to have 3 veins going to it. I have 1 arrow. arrow, there's a superior vena cava. Oops. There's an inferior vena cava. It comes from down below. And I'm not going to draw the other one. The other one's a coronary sinus. It's blood from the heart itself. And again, anything that's going into the right atrium, does it have a lot of oxygen? No. Now everything blue is always low oxygen, although my note, blood is never blue. It's not blue. It may appear blue. That's because of physics and light refraction. It's just as dark red. But inferior vena cava, this is all the low oxygenated blood that's coming from the lower extremities. And it's all going into the heart right there. The superior vena cava is all the low oxygenated blood that's coming from your arms and your head. And I'm like, and it's dumping in right there. So you got unoxygenated blood dumping, two different ways. And the coronary sinus is just coming from the unoxygenated blood or low oxygenated blood that the heart is using, because the heart needs blood too. Now, the left atrium receives blood from 4 pulmonary veins. Now, they're called pulmonary veins. Where'd the blood just come from? The lungs. And so is it going to have oxygen? Just came from the lungs? Yes. And so there are 4 veins. 2 from that lung, and I'm going to draw over my heart. 2 from that lung. That dump in there. You got 2 lungs. Each lung is sending 2 veins to dump its oxygenated blood into the left atrium. In between the atria, I know there's some blood vessels in there. In between the atria, there's a really small wall, because these are small chambers. I didn't draw them to scale. And I'm like, there's a small wall there. It's called an interatrial septum. Inter means between. Atria is because it's between the atria. And septum means a wall. That's what septum means. If someone has a deviated septum, their wall is somehow changed, modified, something. Septum just means a wall. So it just means there's a wall between the 2 atria. Now, in there, before birth, did a fetus need to send its blood to the lungs to get oxygen? No. They weren't breathing oxygen. They were getting all their oxygenated blood from mom. And so I'm like, they didn't, fetus's heart doesn't do all of this. And I'm like, they shunt their blood a couple different ways. And a fetus, when it's still growing, there's a hole that actually connects these 2 atria. It's called the foramen ovale, means a hole that's an oval shape. The foramen ovale. It's an oval hole in the fetus heart. After birth, like immediately, when that baby takes their first breath, that hole starts to close. And then there's just a really thin wall that's just a remnant. It's called the fossa ovalis. It really means an oval fossil. It's used to be where there was a hole right there. There we go. Now, the ventricles have thicker walls, because these are the areas of the heart that's actually going to pump blood throughout the entire body. Into the lungs, but also the entire body. The tips of your fingers, tips of your toes, your heart has to be able to pump and get that blood all the way down there. We've got 2 sides. You've got a right ventricle, and it pumps blood out, I'll make it blue, into what's known as the pulmonary trunk. It's called pulmonary for a reason. Where's it going to go? To lungs. It's unoxygenated blood. We'd like to go get some oxygen, so we're going to send it out the pulmonary trunk. It splits into 2, and it goes out to the 2 lungs. The left ventricle, it has lots of oxygenated blood, because it just came from the lungs. It's going to pump its blood out. I know it goes out through there, little hole, into the aorta, which branches into a whole bunch of very big arteries. And that sends blood out into all of the body. All the way up to your head, all the way down to your toes. Depends on how it's all branching. In lab, we'll see some of these arteries. We'll get the cadavers out, and you'll be able to actually see some of these arteries coming off the heart. Now, inside the heart, and I'm like, there are a bunch of irregular ridges. I'll show you a picture. irregular ridges. The inside of the heart wall is not nice and smooth. There's a whole bunch of little tiny bumps called trabecula carni. Where have you seen trabeculae before? In lab. In the skeletal system. No one remembers. In the spongy bone. And I'm like, the actual rods that make up the spongy bone is the trabecula. And I'm like, and actually the inside of the heart has all these weird irregular looking ridges. Let me find. Maybe. This doesn't like me today. I want the inside. The inside of the heart has all these little irregular ridges on the inside of the heart. It's not nice and smooth. I wonder if I killed the battery. So the inside of the heart has a whole bunch of ridges. It also has various types of muscles that anchor something known as chordae tendineae. And I'm like, it's little tiny cord-like tendons. That's where it gets its name. And there's little tiny strings. There's little tiny strings that are going to be attached to the valves. So there are little muscles that anchor strings that are attached to your valves to help them open and close. Nothing. Yep. Yeah, otherwise there's a whole other type of muscle that runs through it. And then in between the ventricles, just like you had an interatrial septum, wall between the atria, you have an interventricular septum, wall between the ventricles. I'm sad this isn't working. Now, a couple things on the outside, as I pointed out, your auricles that are hanging off the atria. And I'm like, the tip of the heart is the bottom of the heart. Generally, when you look at anything that's triangular shaped, usually looks like the tip is on the top, and then pyramids go down and get bigger at the bottom. The heart is sitting reverse. It's like an upside-down pyramid, upside-down triangle. So the tip of the heart, or the apex of the heart, is near the bottom, and that's really where you're going to have that left ventricle. It's where you're going to find it. The inside has that trabecula carni, and you have the papillary muscles that are going to anchor some of those cords that are attached to the tendons. Now the valves. I tried to get a different color up here when I was doing it. We have valves to ensure a unidirectional flow of blood, one direction only. Blood is going to come into the right atrium, to the right ventricle. It's going to go out the pulmonary trunk, because you have this in front of you, out to the pulmonary trunk, split to go to the lungs, pick up oxygen, come back to the heart, to the left atrium, down into the left ventricle, back out to the aorta to drop off oxygen everywhere it needs to in the body, and then come right back into the right atrium. And it has to go in that order. So we have valves to ensure it's a one-direction flow, that we don't ever have blood going backwards. In between the atrium and the ventricles, we have what's known as atrioventricular valves. So we literally smush the word atrium and ventricle together. We call it atrioventricular. It's nice when they do that. Now, although we call it a right atrioventricular valve and a left atrioventricular valves, which are completely acceptable things to call them, they have alternate names as well. Because in lab, you're going to have to know them, and I don't care which one you want to call it. They're all acceptable things. The right atrioventricular valve, this one, is also known as the tricuspid. There are 3 flaps that make up the valve, and that's where they get it. Cusp is like a little flap. And so it's also known as the tricuspid. I tried to draw 2, just know, I cut one off when I did my 2D image. The left atrioventricular valve has 3 possible names. Left atrioventricular valve. It's also called a bicuspid valve, because how many flaps does it have? 2. And it's also called the mitral valve. Yay. And everyone's like, mitral's a weird name. Yep, it is, and it actually comes from the Roman culture instead of everything from Greek and Latin. I'm not Catholic, but popes wear a fancy little hat. I am really bad as an artist. I don't know, it's like my Jay Leno pope there. That's a pope. If you didn't know it, popes that wear the super big fancy hats, they have a front flap and a back flap, and they usually put something super pretty in between. And I'm like, but that's called a mitre hat. It's where they get the mitral valve name from. And I'm like, that there are two flaps, if you're just wondering where the word mitral valve came from. It's a mitre hat. I don't care what you know them as. Sometimes it's nice to recognize them. They are held and anchored in place by the chordae tendineae, okay, the little tendinous cords that are anchored to those papillary muscles that hold them closed until blood pressure pushes them open. This is not going to let me. This is showing how they can open and close. And so one direction flow of blood. Blood is going to go from the right atrium into the right ventricle. When the right ventricle starts to contract, it's going to contract to try to send blood up there, but when it does, that force, that pressure of the blood it's generating will close those flaps, and so it can't go backwards. And so blood will go down, but when the ventricle starts to contract, force of the blood closes the atrioventricular valve. Same thing. Blood will fill the left atrium, going down into the left ventricle, but when the left ventricle starts to collapse, that force of the blood is going to snap closed the left atrioventricular valve. The last two valves, I'm going to get to the last two valves. I could try to draw this to review on Tuesday, but it's probably not going to look good. Is that we have what are called semilunar valves. It's because they apparently look like little half moons. I tried to draw them. And so we've got valves in between the atrium and the ventricles, atrioventricular. But we also have valves that when that right ventricle pumps blood into the pulmonary trunk, we don't want it to go backwards. And so we've got a valve that can prevent that backwards flow. And so I'm like, since it's pumping into the pulmonary trunk, we have a pulmonary semilunar valve. And I'm like, hold on, I'm like, the left ventricle, when it pumps its blood into the aorta, we don't want that blood going backwards, so we have our aortic semilunar valve, because it's pumping into the aorta. Mm-hmm. The two. And I'm like, the atrioventriculars will give you the lub, the semilunars will give you the dub. Yep. And I'm like, and that will be part of Tuesday's lecture. And I'm like, but yes, you can actually hear, when you hear someone's heartbeat, if you ever put your ear on someone's chest and you hear their heart beating, you're hearing the valves close. So you don't hear a heartbeat. Your muscle doesn't make any sound. You're hearing the closing of the heart. It's interesting if anyone's ever known anyone that's had a valve replacement, because they'll replace those little fibrous valves with metal. And if you ever listen to it, you can actually hear that clink, clink, clink when it closes. And I'm like, it's cool. You should try to find someone that's had a valve replacement with metal. And I'm like, and try to be like, can I be that that person that I'm just going to listen to your heart to be able to hear it? But we're going to end right there.